Okay, example 5, we're going to do the same thing, except we're going to do it using a definite integral instead of an indefinite integral. So how would you integrate the integral of 1 to e of the natural log of x dx? Again, since it's just the natural log of x, there's nothing else there, we do need to use integration by parts. You can't use substitution, and we don't have a direct rule for the integral of the natural log of x. So we do need to use integration by parts. Again, integration by parts is the integral of u dv equals uv minus the integral of v du. Okay, so we have u du, we have v and dv. This doesn't look like a product, but I do want you to think of this as a product. Really, this is the integral from 1 to e of the natural log of x times 1 dx. Remember, anytime you just have a natural log by itself, you have to use integration by parts. Integration by parts, you're always going to make u equal to the natural log of x, and then you're going to make dv 1 dx in this case. Okay, how do you get from u to du? Differentiate both sides. The derivative of the natural log of x is 1 over x dx. The integral of 1 is simply x. And then remember, we're going to say it's uv minus the integral of v du. So this is no different than the previous ones. The only difference is that we got to remember when we do substitution, we need to remember that these limits of integration are x values. So we need to keep them as x values. We're going to have u's and v's now, but when we do this, we need to keep them as x values. So this is going to be equal to, well, now we have to do u times v. So that'd be the natural log of x, which is u, times v, which is x, minus the integral. And again, these still are going from x equals 1 to x equals e. And by the way, we need to evaluate that from x equals 1 to x equals e. And this would be the integral of v, which is x, times the derivative of u, which is 1 over x dx. Okay, so let's look at this. We'd have the natural log of x times x minus, well, x times 1 over x is simply 1, and the integral of 1 is simply x. And then we would usually have the plus c, except here we don't have the plus c because we're evaluating that entire thing at our levels, or at our limits, which is x equals 1 and x equals e. So let's give that a try now. If I plug that in, I'm going to have the natural log of e times e minus e. That's what happens when I plug in an e. And then I'm going to subtract off, well, it's going to be the natural log of 1 times 1 minus 1. So when I do this, the natural log of e is just 1. The natural log of 1 is 0. So again, the natural log of e is 1, and the natural log of 1 is 0. You could get this by your calculator as well, of course. All right, so I'd have a 1 times e is e minus e. That whole first term is going to turn into 0. And then I have a minus, and then I have that 0 minus 1, which is a negative 1. So if I have a 0 minus a negative 1, this would give me a positive 1 is my answer. So what is the integral from 1 to e of the natural log of x with respect to x? You use integration by parts with u equal to the natural log of x, dv equal to just 1 dx. We do the uv minus the integral of v du, evaluate the entire thing from 1 to e. Plugging in e first, 1 second, we end up with 1. Okay, so let's look at this. It says, before starting the exercises in this section, remember that is not enough to know how to use the various integration techniques. The real challenge is you also must know when to use them. So when am I going to use the power rule? When am I going to use the log rule? When am I going to use u substitution? When am I going to use integration by parts? And what they've done here is they've given us 3 examples that look extremely similar, and all 3 of these examples use complete different techniques of solving them. So if you see an integral of just a natural log of x, so natural log of, I don't care, natural log of u, right? Anything's written in there. This is going to be integration by parts. Without a doubt, this problem is integration by parts. If it's just a natural log, use integration by parts, okay? In this class. In other classes, that's not necessarily true, but in this class it is. Okay, look at this one right here. This first one is a product. Because it's a product, Again, it's x times natural log of x. Notice both the x and the natural log of x are in the exponent. This one you would use integration by parts. This second one has a natural log of x, but notice it has an x in the denominator. In this case, if you let u equal the natural log of x, then you would have du dx equals 1 over x dx. So, or sorry, 1 over x. So dx would be, well, it would be what? X du? And when you do that, you'd have the integral of u over x times x du. The x's simplify, and you end up with the integral of u du, which is just u squared over 2 plus c, right? So that would be the natural log of x squared over 2 plus c. And if you look to the right, that's what they're telling you to do, and that's how they got that answer right there. So on this one, you don't need to use integration by parts. In fact, you can't use integration by parts. What you want to use is u substitution. So how did I know to use u substitution? Well, quite honestly, through practice. But on this one, I have natural log on top and x on bottom. If both are on top, you're going to use integration by parts. If both are on bottom, x and natural log of x, you're actually going to use the log rule. Do the exact same thing we did over here with that u substitution, with the u equal to the natural log of x. Well, if you look at this, this would be the integral of 1 over x times u, right? And then didn't we have that the dx was equal to x du? Well, notice what happens. The x's simplify, and we're left with the integral of 1 over u du. And the integral of 1 over u is the natural log of the absolute value of u plus c. So in this case, it's the natural log of the absolute value of the natural log of x plus c. Seems crazy, but that's actually what it would be equal to for those two problems. And you can see that's exactly how they got that answer right there. The natural log of the absolute value of the natural log of x plus c. So three very similar looking problems with three total different techniques in solving them. How do you know which technique to use? Practice, practice, practice. You're going to have several problems on your homework assignment this time, and I am telling you right now that just doing the examples that are required of you, just doing the homework problems, just doing the quiz problems is not near enough for you. Do as many extra examples as you can. Make sure to go into that homework, open up extra practice problems, anything you can do. The more integral problems you do, the more comfortable you're going to be. So when it comes to the test and it doesn't tell you which technique to use, you will know which technique to use right when you start the problem. Okay? So what are the two primary types of problems that you're going to see? You're going to see two problems right here. This is the ones where in this chapter, or sorry, in this section, the main ones that you're going to see is where there's an integration by parts where you have a polynomial times e to the x or e to the whatever it is, okay? And in that case, you're always going to make u the polynomial part, the x to the n part, and you're going to make the dv the e to the whatever it is part, okay? Remember, whatever it is, when it's in this format, whatever that power of x is, that's how many times you're going to have to repeat integration by parts. So for instance, if that was x cubed, you're going to have to do integration by parts 3 times. The second main one that you're going to see is again where you have an x to the n and you have a natural log of x, except this one, unintuitively, you have to make u equal to the natural log of x and dv be the x to the n part on this one. This should only require one integration, and then again the third one that you're going to have to do, that's not in here, it's not in the writing, but the third one that you will do is if you have the integral of the natural log of, well, I don't care what it is, but I'll just put, how about an ax, something like that right there with respect to x. The way that you do this is u substitution again. Here's v and here's dv. You're always going to make u the natural log of ax, and then you're always going to make dv just 1 dx. So that's the technique on those types of problems. The three primary types of problems that you see from here and the three problems that I'd expect on the test are of that form.